Alright, moving on to right triangle trig. Don't worry, there is not a left triangle trig. You get it? This is like right and left. Yeah. Alright. So, this should not be new. We want to talk about the sides of a triangle. If I have some angle theta in a right triangle, hence right triangle trig, then I know that across from theta, or opposite theta, is the opposite side of the triangle. I know next to theta, or adjacent to theta, you see? Look at that. It makes sense. Is the adjacent side of the triangle. And then the longest side, or the side across from the 90-degree angle, is what we call the hypotenuse. So why do we care about that? Well, this is only the opposite side if this is theta. If I put theta up here, or if I call this beta or whatever, then this becomes the opposite side and this is the adjacent side. This is still always the hypotenuse. This leads us to how the trig functions relate to a right triangle. We have this sine SOHCAHTOA to help us remember it, but what we really want to know is sine of theta is the opposite side over the hypotenuse. And remember, this goes back to, we talked about the input of a trig function versus the output. The input of a trig function is the angle. The output is the ratio of sides of a triangle. This is exactly what we're talking about. Boom! Look at that. Cosecant theta is the reciprocal of sine of theta, because they are reciprocals. It's hypotenuse over opposite. Cosine of theta is adjacent over hypotenuse. Secant of theta is hypotenuse over adjacent. Tangent of theta is opposite over adjacent. Cotangent of theta is adjacent over opposite. The SOHCAHTOA, if you don't remember or have never learned, is telling you sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Alright, now let's use that. So, if you are told that the secant of theta is 6/5, I want you to find the remaining 5 trig functions of theta. Pause the video, do that. Unpause when you're ready to see the answers, or compare your answers, because you'll already have your answers. So, we should hopefully know that the cosine of theta is 5/6. You shouldn't have to do any work for that, because you know secant and cosine are reciprocals of each other. To find the rest of these, you should draw a right triangle. So I drew a generic right triangle. I labeled this angle theta, but that didn't matter. What mattered was, once I pick theta, then I have to label the sides accordingly. So if I call this angle theta, I know this is my right angle, the hypotenuse is 6, the adjacent side is 5, and therefore the opposite side is going to be the square root of 11. We get that from our favorite man's theorem. It's Pythagoras, his theorem, Pythagorean theorem. A squared plus b squared equals c squared. Any questions? Okay, once we have the triangle, then we can find sine theta is opposite over hypotenuse. Cosecant theta is the reciprocal of that, or it is hypotenuse over opposite. Either of these answers are acceptable. Remember, we talked about rationalizing before. Not totally necessary, but it's also not wrong. This is when it has to do with numbers. If there are variables, absolutely do not rationalize. Tangent of theta is opposite over adjacent. Cotangent is the reciprocal, so it's 5 over root 11, or 5 root 11 over 11. Alright. Last thing, I want you to think about, in this example, before I did the problem, how did I know theta was not a right angle? So there should be a reason for that. Alright, so just make sure you know how each trig function relates to the sides of a triangle from a given angle, from a given acute angle.